Alright, this build's pretty much complete now, so I think it's time to do a show and tell. I just got this GoPro camera. This is pretty much my first time using it. I have the wind reduction set to auto, but it's probably going to be pretty poor audio. I can't really do much about that. First thing I want to talk about is I'm going to put links in the description for a video that gave me a lot of ideas, most of the ideas for this build, from a guy named Dave. I'm also going to include links for most of the products or items that I used in this build, mostly Amazon links. I also want to talk about how I selected, or how to select a mower for a build like this. This is a 36-inch commercial walk-behind. It's a Honda HRC 7013. The 70 stands for hydrostatic drive, and the 13 stands for 13 horsepower engine. Even though with the new rating system this is only a 10.1 horsepower engine, back when it was made it was considered a 13 horse. It's a very good engine. It's very fuel efficient. It can take a lot of hours, and it has an oil filter. You can still buy this engine today. This is the Honda GXV 390, but I don't think it's available with an oil filter anymore. I don't know how important that is, but that's a distinction. So let's talk about why I think that a commercial walk-behind is the best choice for a build like this. I've seen videos and found forum posts talking about converting a mower to radio control. And a lot of these videos, these guys convert a 60-inch or smaller zero turn, sit-down zero turn. And I think that's a bad idea. A sit-down zero turn is designed to have a 200-pound operator sitting between the engine and the mower deck. That's how it's balanced out to be. A commercial walk-behind is designed to operate without an operator on it. So I think the balance proportion is better for a commercial walk-behind. That's just my opinion. I don't really have a lot of facts to back it up. Now, the video that I referenced earlier, he converted a belt drive or a gear drive, which has a transmission that you shift with your knee, and the wheels are driven by a belt drive. He had to use wheelchair motors, 24-volt wheelchair motors, and two batteries, two 12-volt batteries to get that 24 volts. I feel there's an advantage going with a hydrostatic drive. This one has separate pumps and wheel motors. These are Hydro Gear pumps, and the wheel motors were made by Ross, who is now defunct. They were bought out by Parker several years ago, but I believe the factory is still running today. I could be wrong on that. One of the advantages of going with a hydrostatic drive is you only need one 12-volt battery. This is just a typical U1 battery like you'd have on any lawnmower, and I don't need another one. Also, I do not need a alternator. I did buy an alternator, and I had a plan to install it if I needed it, but this 10-amp charging system that's under the flywheel, that I also have a link in the description for the parts you need for it, it works with this rectifier regulator here. That's $10. I think the charge coils were $90. That provides 10 amps of charge current, and it's all this system needs to maintain a full battery all the time. I never have to charge the battery with this, which I think is pretty sweet. And I don't have to deal with the complications of having an alternator and another belt drive underneath, which is good because there's not a lot of room under here. With the hydrostatic pumps, you don't really have room to mount an alternator. You can see I did have a plan to do it, but those pumps take up most of the space you're going to need for an alternator to be mounted, and it's going to complicate replacing the belts that you have to replace due to wear over time anyway. This system right now only has two belts. It used to have three. I'll get into that later, but it used to have three belts. Now it only has two. It only needs two belts to operate. I didn't want to say but I did. So I think there are advantages of hydrostatic, and I could not find any videos on YouTube showing what you needed to do to convert a mower to radio control with a hydrostatic transmission. This is all new. And if you guys know of any videos, please mention them in the comments. I want to see them. So the first conversion I did to this mower, when I first got this mower, it was electric nothing. It was pull start only and manual PTO, which is a throw lever right here. You do not need to have electric start in order to convert a mower to radio control, but you do need the ability to remotely disengage the blades. So you need an electric PTO, and that means you need a charging system. So this mower did not have any magnets in the flywheel. There was no stator to charge the battery at all. And Honda provides a couple of three different levels of charging systems that work under the flywheel. They have a 3 amp, they have a 10 amp, and I think they have a 20 amp. I could be wrong in the last one, with different stators. I installed the 2 stator system, the 10 amp system, under the flywheel on this. The conversion to electric start is really easy. You have to buy a starter with the correct number of teeth. There's 10 tooth and there's 14 tooth starters depending on your flywheel. You need a flywheel with a ring gear on it and a 4-pole magnet. It has to be a 4-pole magnet for the 2-coil system. All the holes are already present on the mowers, or the motors that do not already have electric start. You just have to tap them out. So I tapped the 4 holes out under the flywheel for the coils to 1/4-28. I didn't have metric taps at the time, and I tapped out the 2 bolts for the flywheel, or for the starter, at the same time. I had to cut a small piece of plastic out underneath this shroud to allow access for the input pinion, but it's pretty simple. Then I had to buy a battery, and I made the mounting system here with a strap. And you can buy these metal straps at any True Value hardware store. I just bent them to shape, made what I want, and I put a nylon strap around it to hold it in place. Works really slick. Super easy, super cheap. The starter, I think, was 60 bucks. I bought the flywheel off of eBay for 80 bucks. And the charging coils were $90. So that's an upgrade that I highly recommend anybody do to their mower. Super easy to do. Yeah, way to go. After that, you need to have a charging system for an electric PTO because it's going to draw between 4 and 5 amps. It'll drain your battery pretty quickly. So the next thing I had to do was convert from a manual PTO to a electric PTO clutch. And I didn't really know how to find the right PTO clutch. I found my crankshaft diameter was 1 inch with a 1/4 inch keyway, and I just went on Amazon and searched, and I found one that I thought would work. I wanted a low profile one, and I was approximating the diameter of the drive pulley. You want to get the drive pulley diameter correct because you don't want to be messing with your blade speed that much. The manufacturer recommended blade speed is important to stay close to. Don't go under, don't go over by very much. It could be dangerous. Also, when I pulled the manual PTO out, I thought this was interesting. I'm glad I found this. This rod used to run from down here underneath the front of the mower. And you can't see this section right here. But if you look at it, it looks like a beaver chewed on it for about 50 years. I don't know how long I had before that let go, but that's not in very good shape. So manual PTO reliability versus electric, I don't know if that's a viable argument. There were some complications with the PTO installation. The biggest one was it dropped the height of the pulley by about 3 to 4 inches, which misaligned my deck drive belt. So I had to completely redesign the deck drive. It used to be that a deck drive belt came over here and drove a pulley up on top of this spindle. about 2 inches higher than where it is right now. So I had to eliminate that pulley. There was this spindle then drove another belt to this pulley and drove this blade by itself. So I dropped everything down to level it, and now I'm driving both spindles with the same belt. That took quite a few days to sort through and get working correctly. Another thing that I did, I'm pretty proud of this one actually, was I had to figure out a way to mount the anti-rotation bracket to the PTO without accidentally drilling a hole in the bottom of the sump of the engine. So I took one of those same straps I used for the battery mount and I joggled it over, and then I took a bolt, cut the head off, and made a stud that bolts to the PTO clutch. So now that's my anti-rotation bracket, and it works really slick. I'm pretty proud of that one. It's a good idea. So after I got the PTO clutch, I also had to buy a PTO switch, and I bought a digital voltmeter. The digital voltmeter turns on with the key in the on position, and right now it's reading battery voltage at 12.6. It's 0.1 volts off, so this is actually at 12.7 volts right now, but it says 12.6. The telemetry function on the transmitter is correct. Okay, when you have the PTO switch engaged, you cannot crank the engine. I have it wired up that way. If you engage or disengage the PTO clutch, then it'll crank. I have retained the ability to start the mower and kill the engine with the key or the transmitter. I can also you cannot engage the blades of the transmitter unless the PTO clutch switch is pulled out. So if it's in, you cannot engage the blades. This means that anybody who needs to can approach the mower, disengage the blades, and kill the engine without touching the transmitter. This is a safety feature that I've incorporated. Let's see. So now that pretty much explains the PTO system and how that works. Let's go on to the servos. The servos for this mower are what makes or breaks the ability for it to work. And I had a hard time finding servos that I thought would be strong enough to do this. Hi-Tech makes a couple. They've got an HS 1000 SGT, a 1005 SGT, and a HS 1100 WP. But those servos are extremely expensive. The 1100 WP I think was $600, and I couldn't find any of these in stock in the United States. I was going to have them shipped from Japan. But then I found the ones that I did ultimately buy, which are the Pro Modeler DS 2685 DLP, I think it was. They're $260 a piece. These servos are cheaper than a gear set for the Hi-Tech servos. And these things have some stones. They got some balls. They run it up to 15 volts. They're a 5-wire servo. You've got to connect all 5 wires. 3 of them go to the receiver, 2 of them go to power. And with a 12-volt system like this that charges it up to 14.5 volts, they are ideal. This is the perfect servo for this kind of build. I also bought the 2-inch wheels, and I drilled and tapped the innermost holes that had enough meat around them for it to M580 thread pitch instead of M3. I just didn't think the M3 was going to be beefy enough. So yeah, 5-wire servo has to go to the all 5 wires have to be connected. You can't just connect a signal wire to the receiver. You've got to have both positive and negative to the receiver as well. I also had to have some wheels made for the pumps, and these cost me $100 a piece. I drew up a print myself, gave it to a local machine shop, and I had them make me these wheels. And I made them so that I could have the rod ends as far as possible from the center of the shaft as I could get. Then I took a cutoff wheel and a Dremel. Let me turn that off. And I machined these notches into it. I repurposed the blade guides, or the belt guides, that I'm not going to need anymore, so that I can use them to tell me when the marks are lined up. But this would be full forward. I come back with it to neutral, and then this one here is full stop in reverse. It's kind of hard to push it, but alright, you got it there. So that's full stop, well, almost full stop reverse. The upper rod end, or the upper control rod, is slightly shorter than the bottom one. I did that intentionally so I would get more forward throw, more throw in the forward direction than reverse, because I need to go faster forward than I need to go in reverse. That's the reason I did that. So it's important that you get both of the rod ends connected at an equal radius from the center. If you have one of them closer to the center than the other, as it rotates, the linkage will bind up and it will not work. So they can be off a little bit forward or aft, but they've got to be exactly the same distance from the center of that hub, regardless of the length of your control rods. I had these machined out of 304 stainless, and the shop bitched about that quite a bit. It's pretty tough to machine, but I think I needed it. I mean, I didn't want to have to heat treat these. I didn't think mild steel was going to be strong enough to last without wearing out. And I ended up with a by extending these out as far as I could within reason. I mean, I'm going to hit these fittings, or hit the actual structure of the lawnmower down here if I go any further. I ended up with a mechanical advantage to the servo of about 2.5 to 1, which I think is important. First of all, it reduces travel, increases resolution in your controls, makes it more easier to control, and it gives the servo a break. It doesn't need to be as strong if you're giving it a mechanical advantage. So that was my thinking on that. And then, excuse me, then the other thing I needed for the build was battle switches. And I had never heard of battle switches until I saw that video from Dave. That's where I learned about battle switches. What they are is they are receiver operated relays, and you can wire them up normally open or normally closed. I've got all three of these wired up normally open, so if I lose power, if I lose my 5 volts of power to the receiver, they all open, which kills the engine, disengages the blades, and you cannot engage the starter. That's another safety feature that's incorporated into this. Along with the battle switches, I also needed a buck converter. So this converts 12 or 24 volts down to 5 volts DC, and that's what operates the receiver. And the receiver is a Spectrum AR8020T. The T stands for telemetry, and I'm using the telemetry function to give me system voltage from the battery, the main battery. So I've got 5 volts going to the receiver, and I've got up to 14.5 volts going to my servos. And my transmitter will tell me that remotely. I've got a digital readout right on the front of it. Let's see. What's next? Okay, also, I have incorporated a gyro. And nobody online could tell me how to do this. I had to figure it out on my own. I've had this gyro for over 20 years. I bought it, put it on a Hyrobo Ski-Doo helicopter, 50 size nitro heli that I crashed when the receiver battery died on a cold morning, and I was having a hard time getting it started. And I took it off and put it in a box, and it's been sitting in the attic for 20 years. But now I've brought it back out, and it's got new life. I'm running it on channel 5. The sensitivity signal wire is going to channel 5, and that's also the same port that I'm using to put the 12 or the 5 volts of power from the buck converter into the receiver. You can put your receiver voltage into any one of these ports. They all share the same positive rail. So it doesn't matter what port you put them into. This one was only using the signal wire, so I just pinned it for the positive and negative, and now that's my power to the receiver. I control the gain function in the transmitter by adjusting the travel, and I've got it cranked all the way to 150, and it's not twitchy. I also have the delay at 0. I have the digital servo switch set to on. It's a digital servo. I have direction reversed that I needed to. I don't know why, but it had to be reversed. And I have the limit switch, or limit potentiometer, is set to maximum travel. And that gyro really makes this mower handle a lot better. You can drive, it's far easier to drive it in a straight line now with the gyro. I'm running the gyro in rate mode. It does not work in heading hold mode because it keeps changing where it sets neutral. So as you're operating the mower, when you get to the end of a row and go to stop by putting the stick in the center position, this will either be reversed or in forward, and that wheel will continue to turn. It doesn't work. I set up my Spectrum DX8 to operate the controls, or the two direction controls on this stick. So this is forward, reverse, left, right, just one stick. This stick does nothing. It's all inhibited. There's nothing on the throttle. So yeah, I think I mentioned this earlier. These servos are really the key to this system. I had to fabricate these mounts, and that took quite a while. I don't have a machine shop. I don't have an end mill, so I had to cut these openings out of this 3/8 inch thick aluminum. I used a Dremel for one, and that wasn't fun. And I chain drilled the other one and cut it out and filed it. That took several hours. If I had an end mill, that would have been a blessing. I also had to drill and tap the mount screws. Those are M3 50 pitch, all 4 of them. And I used quite a bit of taps on this build. I had to tap quite a few holes. It wasn't just 1 or 2. So I'll put this back together. I'll start it up. I'll try and demonstrate the servo functioning, or the gyro functioning, and show you how it tries to correct when I push on the front of the mower with my foot. You're not going to be able to feel what I'm feeling, if that makes any sense, as far as the difference between gyro being on or off. You might be able to notice a difference in the sticks and how straight the mower is going. I'm going to do 4 passes. I'll do 1 out, 1 in with the gyro on, and then I'll do 1 out and 1 in with the gyro off. You should be able to see some difference, but you're not going to be able to feel it as intently as I do when I'm operating it, because it makes a big difference to me. But I mean, you're not controlling the mower, so you're not going to have that same sense that I do. So let me put on my chest mount here. I'll sit the camera down for a second. Face. Sorry about that. How does this damn thing work? I'm new to this camera, guys, and this chest mount, so bear with me. Okay. Well, I think the mower's in frame. I did all the mixing in the transmitter. And it might not be done the best way possible. I may go back and redo it again, but I've got it pretty well fine-tuned, and I like where it's running right now. It's just I wish it would go a little faster. I have more room and forward travel before I hit the limit, but with left and right I get binding, so I've got it going about as fast as I can right now without having the servos bind up. You do not want binding in the servos. It's bad for them. All right. So I've got this configured. This is my kill switch. So this is engine kill, this is engine on. I'm using the bind button for the starter, and I'm using the B switch to engage and disengage the blades. I've got a toggle switch here that puts power to the 5-volt buck converter. So if you turn that off, it cuts power to the receiver. So we'll see if it'll start up. So I think that was pretty obvious how much of a difference the gyro makes. It doesn't need to operate both wheels. It just needs to control one, and it can correct for yaw and make it a lot easier to mow a straight line. So that being said, that concludes this video.